the very similar as yesterday's, the LeetCode construct binary tree from Inorder and Postorder Traversal. So in this question, LeetCode 106, we can find 3, 9, 20, 15, 7. This is 2 Inorder and Postorder lists. Based on these 2 lists, we need to find the right output. So the first thing is, where is the root? The root should be the Postorder last element. So which is Postorder size, which is 0, 1, 2, 3, 4. So Postorder 4 should be the root for this tree, for this whole tree. Then once we find the 3, we can find the index in the Inorder list, which is index 1. And based on index 1, we can find left subtree and the right subtree. So left subtree is 9, and the right subtree is 15, 27. Based on the left subtree 9, we can find Postorder 9 here. Then this is the left subtree 9, and the right subtree is 15, 7, 20. And then we have another recursion here from the last. So the next root number is 20. So we have 20 here. And then based on 20, we can find the index here. 0, 1, 2, 3. 3 is the index 20 here. Then we can find the left 15 and 7. So 15 and 7 is in here. So we can do one by one after that. So let's see the code. If you want to see how the 15 and 7 happen, it's like once it's we see the last root is recursion is 20, then we can see the next is 7. So 20 right is 7, 20 left is 15. So that's the we can get this to reconstruct the binary tree. The code is very similar as my last video. We can see index input in the Inorder and the Postorder. We need to create a hash map for Inorder, so we can know Inorder index is 0, 1, 2, 3, 4, and we can see the key and value here. Then we do the in left and in right. Inorder left is 0, left bound is 0, and Inorder right bound is Inorder.length minus 1, and post left left bound is 0, post right bound is Postorder.length minus 1. Once we have all these parameters, we can do the recursion, return the helper function here. Inorder index, that's the map, hash map here. Then Inorder left bound, Inorder right bound. Then Postorder is the Postorder list here. Postorder left bound, Postorder right bound. Then in the private function, tree node helper here, the base case is, say, if the Inorder left is bigger than the in right, index, we return null. Since if left is bigger than right, we need finish the recursion. Then what's in recursion? First, we find the root. The root is the post order post right. So, for example, here, the first root is 3. It's in post order, and the post order size -1, which is this one, which is 3 here. Then we can, based on the 3, we can find the index in the input order list. So 3 is here, the root dot value is 3, and the in-order index dot get 3. So in-order index, the hash map, we can find 1, 3, the 3 number index is 1 in the hash map. So in mid index is 1. Then we do the recursion root dot left and root dot right. In root dot left, we have 6 parameters. First 3 is in order, in left and in right bound. So in order index, in left 0 now, in mid index -1. So for now the mid -1 is the left subtree. And same in here. The first 3 parameters is in order index and the right subtree. So in mid index +1 is 2, 2, 4. +1 is 2, and in right is 4. And then in the root dot left post order, we also have 3 parameters. In the post order here, post left is here 9, and the post right is post right minus post minus in right. So 4 minus 4 plus in mid index. In mid index -1. So in mid index is 1. So 1 minus 1 is 0, which is 0, 0. So it's 9 here. So it's 9 here. Then in the right root dot right post order list, we also have 3 parameters. Post order list, then we have from should be 15, 7, 20, except 3 and 9. Since 9 is the left subtree and the 3 is the root, we already recursed. So this should be post order, then post right minus in right is 4 minus 1 is 0, plus 1 plus 1 it's 2, so 2 is 7. Wait a second, what's 7? Let me see. Post right minus in right is 4 minus 1. 4 minus 4 is 0. In mid index should be 1, yes. Then plus 1 is 2, so it's 7. Okay. Then post right minus 1, post right is 7, is 4. 4 minus 1 is 3, so 720. So the root dot right is 7 to 20, 2 to 3. Let me see here. Here per in order index in index plus 1 in right post order. Okay, post right minus in right plus in mid index plus 1. 720, so 7 and 20 is here. This is root.value. Root.value is 3 here. So this is 1. And index is 1. So it's 7 through 20. We have 9 included. 720 is the right. Oh, so next is 15 is the left. So it's right. Because 720 is the right subtree. 15 is the left subtree for the root 20. Since in the next time, 20 is the root. So it returns null because left plus is larger than right. You can see for the next time, in left, which is 1 here, and in right, which is 4 here. Then next time we have in left is minus, it's 0. So it was 0, 0. Then next time is 0 minus 1 should be negative 1. And the negative 1 is 1 bigger than negative 1. That's correct. So we need to return null. That's how the recursion goes. Then time complexity and the space complexity, they are the same. We need for time complexity, we need a traversal all the node, so it's ON. And space complexity, we also need to generate all the heap, all the hash map here, which is also ON, O node. That's it.